Hello friends, welcome to my channel Economica. I, Dr. Gopal B. Saraswat, welcome you all to my channel. Today, in the series of Applied Econometrics, today we are going to learn Descriptive Statistics using EViews, wherein we are going to take a data and we calculate descriptive statistics and interpret the results. First of all, we need to understand about what is descriptive statistics and why it is necessary. The basic statistical analysis is known as descriptive statistics. Descriptive statistics can be summarized as a responses from large number of respondents and a few simple statistics. So when we are dealing with a data like time series data, we have a large sample size, maybe a 10-year data which is divided into the daily data. In such scenario, descriptive statistics especially very helpful because it summarizes data using few observations. So when your obtained sample is large, you can use the descriptive statistics to characterize the data. So basic statistical analysis is known as descriptive statistics, and here we use generally mean, median, mode, variance, range, standard deviation and other widely applied descriptive statistics. The first thing we generally use in descriptive statistics to describe and characterize our data is known as histogram. The histogram displays the frequency distribution of the series or the data you are having. Histogram divides the series range into a number of equal length intervals or bins and display a count of the numbers of observation that fall into each bin. So from histogram we can easily identify whether our data is normally distributed or not. Further, mean is another descriptive statistic tool which we use for the purpose of characterizing the data. It provides the average values of the series by adding up all the series numbers and divided by the number of observations, and we get the average or the mean of the series. The third descriptive statistical tool is median, where we try to find out the mid value of a series. Mid value of a series provides us a midpoint of a series where we can find out how many observations are below this midpoint and how many observations are above this midpoint. Further, another descriptive statistical tool is maximum values and the minimum values, where we try to find out how many values lie above or considered to be the highest values in the series or of data and which particular value is the minimum in the data. Next one is standard deviation. This is a measure of dispersion or the spread in the series, which provide us how the data is varying over a period of time or the variation. Then next descriptive statistical tool we generally use is skewness. Skewness is a measure of asymmetry of distribution of the series around the mean. The skewness of a systematic, or you can say the skewness of a symmetric distribution such as the normal distribution has to be zero, and the positive skewness means that the distribution has long right tail, and the negative skewness implies that the distribution has long left tail. So here you can also see that negative direction, positive direction, and if your data is normally distributed, there is no skewness. Skewness seems to be 0. Finally, the last one in the descriptive statistical tool is kurtosis, where it classifies a curve as a leptokurtic, mesokurtic, and platykurtic. So in kurtosis, a leptokurtic curve seems to be, as here you can see the red one, which seems to be very steep. Mesokurtic is a normal curve, and platykurtic seems to be lower than the normal curve. But how we are going to identify whether my series is a normal or not, or how kurtosis help us to find out the normality in data? The kurtosis of the normal distribution has to be 3. If your kurtosis value exceeds 3, the distribution is peaked or known as leptokurtic. If the kurtosis is less than 3, its distribution is flat and known as platykurtic. And if the distribution of the kurtosis value is 3, then this is known as your data is normally distributed. So finally, as we characterizing the data using different descriptive statistics tool, the another tool which we are just trying to identify over these using these tools are normality. So in normality, we in EViews we generally use Jar-Kibera test, and this test statistics provide us a clear-cut answer whether our data is normally distributed or not, because this test statistics measure the difference of skewness and kurtosis of the series with those from the normal distribution. So under the null hypothesis, this test consider that data is normally distributed, and if the probability value is less than 5%, this means that your data is not normally distributed and the null hypothesis get rejected. So these are the different tools we use in the descriptive statistics to characterize the data set. Now let's move to the EViews, where we are going to calculate descriptive statistics and then interpret the results. Here we have a data set of Brazil, where we have the Brazil stock market index values, the closing rates from 1st January 2008 till 1st January 2018. So this is around 11 years of data. Then we have exchange rates of Brazil, which is also from the same timeline. Now we would like to first know how they both are having a relationship. So as I told you earlier, that we can produce a graph using both the series. I already prepared a graph for you, and here in this graph, for example, if I open this as a group, I am closing the earlier both. This is the group series. I go to view, graph, and then I go to a basic graph, line and symbol graph, where I want axis to be different. One in the right, another one in the left, and here is my graph. On this graph, in the blue line, you can see the exchange rate, which is against the USD, and another one is the Bovespa, which is the index value of stock market of the Brazil. We can see that whenever the exchange rate decreases here means whenever the value of Brazilian currency is increasing. This is in the local currency. So if the value of local currency increases against US dollar, so here we can see that the market comes down and vice versa. There seems to be a negative relationship here. But over a period of time, the market seems to be more volatile than the exchange rate. So this is a basic information we got from this one. But now moving ahead, we are more interested in the descriptive statistics. So how we calculate? First, I open the Bovespa series, the Brazilian stock market index. I go to view. I go to descriptive statistics and test. I click on the first option, histogram and stats. Once I do this, this has provided me a histogram, which is the very first thing of my descriptive statistic tool as we discussed just now. And here we can see from the histogram it seems to be a normal, but it also seems to be a, uh, a curve which is highly steep. So let's see this how we have to first interpret these results provided by the EViews. So let's start with the histogram. Histogram is showing it may be a normal distribution, but this graph will be, because here you can see this one is highly steep. Data is gathered in the center. So we feel that the data may not be a normal distribution. Then moving ahead, in the right hand side, the mean is available for the stock market. So this is the mean of the stock market. This is the median of the stock market. Maximum value, the market hit 12,873 point during the last 11 years. Minimum 4,313. So this means that there is a huge difference between the maximum and minimum. So this means that the standard deviation may be high. The standard deviation, as we can see, 1324.321, and this seems to be very high. Skewness, which is the measure, another measure of our descriptive statistics, which is 0.004. This is very near to 0. So we can say that the data is normally distributed. But again, as I told you, this is highly steep curve. So in highly steep curve, we have to move to the to confirm this whether this is normally distributed or not. We can use the kurtosis value, which is 4.44. And as I just told you, when the kurtosis value is greater than 3, this means that the distribution is peaked and leptokurtic, and this means that this is not normally distributed. Further, to confirm the normal distribution, the Jarque-Beira test, the value is 227.06 and the probability value is 0.00, which is less than 5%. 5% means 0.05. So if this value is less than 0.05, so this indicates that we have to reject the null hypothesis. What is the null hypothesis? The null hypothesis is that series or data is normally distributed, but as the value of probability is 0.00, so we can reject the null hypothesis and we can say that data is not normally distributed. So this is the first index, or the Brazilian stock market index. Similarly, we can produce the result for the exchange rate. In case of exchange rate also, mean, median, maximum, minimum values. Here the standard deviation seems to be low in comparison to the stock market. Skewness again greater than 0, and this is positively skewed. Kurtosis less than 3, or less than 3 means this kurtosis is distribution is flat and platykurtic, which is not normal. Jarque-Beira test is probability is less than 5%. Again, we have to reject the null hypothesis, and null hypothesis was series is normally distributed and has to be rejected. So this means that this series is not normally distributed. And finally, the histogram, if you can see that here there is no normal curve seems to be there, because the data is somewhat, you can see that, is leftward moving and leftward centered and distributed not evenly and here and there. So we can say that this is how the descriptive statistics help you to characterize your data and help you out to have a feel of your data. I hope you like my video. Thanks for watching.